Hi everyone, this is the third in the series of confidence intervals that I'm going to discuss. In this video, we're going to take a look at means. So means is a little bit more complex than doing confidence intervals for proportions. Proportions are pretty straightforward. If you have a large enough sample size and there's some limits in terms of what you can do with it. But basically here, we have to look at the original population. If we don't know that the original population is normally distributed, if it's skewed for sure or something else, then we have to have a sample size of at least 30 to even begin to think about it. If it's not normally distributed and we have a very small sample size, you cannot calculate a confidence interval. I shouldn't say you can't. Mathematically you can, but it has no value. So on the other hand, if we know that it's normally distributed, then we can come over and follow this line. But either way, we still are dependent on whether we know sigma. What is sigma? Sigma is the standard deviation of the population. Very rarely do we know it, but if we do, then we can use what they call the Z distribution for our confidence intervals and Z critical values. If we don't know the standard deviation, sigma, for the population, then we must use the T distribution. And it doesn't matter what the size of the sample is, we're going to head in either one of those directions. So now I'm going to talk about the two kinds. Confidence interval, the first thing we need to know is we need the critical value. So if it's a T distribution, if it's a Z distribution, we can use critical values, the same critical values we used for proportions. And I mentioned those in the last video. If it's a T distribution, we're going to want to use the T tables. Or we can use the templates, which will do the calculations for you, and I'll show you those formulas. You'll also need to know, if you're going to use the table, you're going to need to know the degrees of freedom. That is going to be whatever the sample size is minus 1. Why? Because each distribution, unlike the Z distribution, the Z-score distribution, standard normal distribution, the T-score distributions look almost like that, except they're not as tall, which means there's not as many values that cluster around the mean of the standard normal, and there's more values that end up outside in the tails. So the distributions of T distributions are totally dependent on the sample size, and there's a different one for each one. Not really a big deal because you can use a table. Like the proportions, we're going to find the confidence intervals by taking our statistic. This time, not a p-hat, but this time being an x bar. We're going to take the x bar and we're going to subtract, and this is the formula for the margin of error, from the statistic x bar, the mean of the sample, to get our lower bound, and we will add that margin of error to the mean to get our upper bound of it. So let's take an example, okay? The data here represents home fires started by candles in the past 7 years. Find the 99% confidence interval for the mean number of home fires. So the first thing we got to do is find the mean and the standard deviation. We need these values and we need n, the count. So how did I get these values here? Well, I went to my Excel spreadsheet, okay, and I scrolled over to, let me see here. I need to get this, there we go. Okay, I need to get all the way over back up here to, well, even further back to descriptive statistics. I put the values in. Be sure if you have any other numbers in here, okay? If there's anything else lingering in those values, you see how everything changes? So you've got to make sure that there's nothing else in this column because it will automatically do the calculations. And it calculated my mean for me, and it calculated my standard deviation, and it calculated the count. That's so useful when it's a small set of data like this, but very, very useful when it is a large sample. Okay, so coming back to my slide here, these are the values I got. So once I have those values, Then what I need to do is I need to put them into the Excel spreadsheet. And the Excel spreadsheet I'm going to use is the T interval for the mean. You see I put in my S, which is my standard deviation. I put in my X bar, and I put in my N7. And I come down here and I look, I put my confidence interval in, which was 95%. It rewrote it, the critical value. It looked up the critical value. Now, this is the calculation for the critical value is here. This is the function that I used. But you can get that critical value by using, I'm going to pull it over here, the T table. And so if you look up the degrees of freedom, there were 7 items, so the degrees of freedom is 6. And you look up and down here at the bottom is the confidence interval. 95% confidence interval, so I'm going to come up right this column here and go to 6, and there's 2.447. And notice that my calculation was 2.44. It calculated it out a lot further. But the T table will give you the same value. So there's your critical value for your T table. Okay? It calculated the margin of error by that formula that I just showed you. Okay? And then it took the value of the X bar and subtracted the margin of error to get the lower limit and added to get the upper limit. Okay? So that's a T schedule. So remember, we're going to use the T interval mean. Now, on the other hand, if I know sigma, and the problem will say something about it. So here I have a researcher, 50 cars, mean time on a dealer's lot was 54 days. So 54 days is my X bar. Okay, standard deviation is 6 days, so I know the S. But notice it, and it says standard deviation of the population. So that's not S, that's sigma. And I want to find a 99% confidence interval. Formula is the same, but instead of these, I'm using Z, and I'm not using S. I'm actually using a sigma here. Sigma here and sigma here. Okay? This time, on my formula, I'm not going to use the T interval function. I'm going to use my Z interval function. And I'm going to come over here and I'm going to put in my confidence interval, sigma, put in my value for sigma, which is 6, my X bar, which is 54, my N, which was 50, and it will do the same calculations that it did for the T. But notice the critical value now is based on the normal inverse function and not the inverse T function to get the critical value. So you can look at the formulas here if you're interested in building your own spreadsheets. The formulas are there to help you out with those as well. Okay? Now, in the same token, I can ask, what if I want to pick the right sample size for it? Proportion, or was in this case not catch the proportion, but the mean. Well, if I do that, what I need to do is I'm looking at N is equal to Z critical times the sigma divided by the margin of error. Okay, and I have that in the function as well. You will find that here under sample size, and it will be over here. If I go over here a little bit, confidence interval, critical value, sigma, and E. Put in those values, and it will give you the size of the sample that you need. Keep in mind, a reminder again, that you must round up when you're doing sample sizes or you'll get the wrong answer. Thank you.